Okay, in this video, I'm going to go over analyzing a few graphs. So we're going to look at the graphs and we're going to do some major characteristics of the graph, all of which you'll need to know for our exam coming up. So we're going to go through the domain, the range, any asymptotes, any continuity or discontinuities, increasing or decreasing, concave up, concave down, whether this function is odd or even, the local extrema, and the end behavior. The first thing we're going to need to do is graph this function. So just right here, I'm going to do some step-by-step graphing. So I'm going to start with x squared. So x squared is going to look like this. And then x squared minus 4 is a shift down. So 1, 2, 3, 4. It goes up like this. And that crosses at 2 and negative 2. And then finally, we're going to do the absolute value. Now, the absolute value takes this part and brings it up. So I'm going to go over here now and draw the rest of the graph. So we're going to go, I think I'm going to make each of these 1. So this is 1, 2, 3. Okay, so we'll do every 2 here. Negative 3. That means you gotta go 1, 2, 3, 4. And this was at negative 4, so now it's at positive 4. We're going to go down to negative 2, so it's going to go like this. And then this one's going to curve down to like this. And then come back up like this. Like that. So we're going to have some sort of little W here. So now let's go ahead and take a look at let's take a look at the domain and range. So let's just get these out of the way here. By the way, I'm going to go over 2 problems here. I'm going to try to go as quick as possible, so you can pause or rewind wherever. I think that you should really try this on your own and then go through the video. So this is really just for you to check your work, but I wanted to be able to explain it anyway. So the domain here, the domain goes all through the x's. So we're going to have a domain of negative infinity to positive infinity, so all real numbers. The range, however, starts at 0 and goes up to positive infinity. There's no y values down here. So the range is from 0 to positive infinity. There are no asymptotes in this case, so we'll just say none. The continuity, this is a continuous function all the way around. It doesn't have any jump, infinite, or holes in the graph. So we'll say it's continuous in all real numbers. So we'll either do this, or you can say no discontinuities. I know my handwriting is atrocious, isn't it? Okay, decreasing interval. So decreasing interval, we're looking for where the tangent line is going to be negative. So here, notice that if I drew a tangent line here, I would have a negative slope. Here I'd also have a negative slope, like that. But over here, those I would have a positive slope. So you could see that here I would have a positive slope, positive slope. So those would be increasing. So in this intervals, they're increasing. In this intervals, they're decreasing. So the increasing interval is going to be from negative 2 to 0. And we're looking at the x values, okay? Negative 2 to 0 and 2 all the way out to infinity. So 2 to infinity. And then the decreasing is going to be from negative 2 out to negative infinity, and from 0 to 2. So we're looking at the interval here. So negative infinity to negative 2, and 0 to 2. Okay, so now we're going to look at where it's concave up. It's concave up. It goes concave up here, and then right here it switches to concave down, and then it goes concave up again. So it's concave up all over here, and concave up all over here. So it's concave up from negative infinity to negative 2, and from 2 to infinity. Then it's concave down all inside. So it's concave down from negative 2 all the way to 2. So we're going to go negative 2 to positive 2. Okay, now is this an odd or an even function? Well, to determine that, we look at the symmetry. This is not symmetric about the origin. In fact, this is symmetric about the y-axis. So here's the y-axis. It goes back and forth here. It's like a mirror image. So we know that symmetry about the y-axis is an even function. So this is even because it has symmetry about the y-axis, which makes it an even function. Okay, extrema. Well, notice here that this goes down and then goes up, so there's a peak here. It's not really a peak, it's a low value, and then up and then down again. So there's a relative max. It's relative because there are values of y that are going to be higher over here. There's a relative max at the point 0, 4. So we're going to say relative max at 0, 4. Again, this is a point. And we actually have, this is the absolute lowest value. There will be no lower values of y. So we've actually, in this case, got two absolute minimums. So we're going to say absolute minimums at, looks like negative 2, 0 and 2, 0. Okay. All right. Lastly, we have the end behavior. So I'm going to scroll down just a little bit. Oh, oops. Let's go back up there. All right. So the end behavior. The end behavior we're going to write in terms of limits. So we're going to have the limit as x approaches infinity of f of x. Now, what happens to the y value as x gets larger and larger? Well, as x gets larger, y also gets larger. So this is actually going to be infinity because y is going to go out to infinity. And the limit as x goes to negative infinity, oops. Excuse my, oops, that's not what I wanted. I'm going to erase it. As x goes to negative infinity of f of x. As x goes to negative infinity, as x gets infinitely smaller negatively, y goes all the way up. So y is going to go to infinity. Okay, so this is one example, and I'll go on to the next example right now. So let's clear that out. And our next example, you'll notice that it's just a similar problem, only now we're going to have the reciprocal. So we're going to start with our previous graph, which looked like like that, and now we're going to do the reciprocal of it, which means we're going to have vertical asymptotes here and here. Okay, so we're going to have vertical asymptotes at -2 and +2, and then everything is positive, so it's going to go like this, and then it's actually going to cross through 1/4. So up, up, and across like that. Okay. So the domain here is going to go from negative infinity to -2, union -2 to 2, union 2 to infinity. Again, because we've got those asymptotes, the range this time is going to go from 0 to infinity and not including 0 because we've got a horizontal asymptote. Our vertical asymptote here is at x equals -2. And we have another one at x equals +2. We can see that from the graph. We could have also solved it by putting the denominator equal to 0. And our horizontal asymptote, because we've got big over little over big, will be y equals 0. Continuity, this has an infinite discontinuity. And the decreasing interval, well, decreasing is going to be here to here and here to here. So we're going to go from -2 to 0, and then again from +2 to infinity. Now you could make these brackets if you want. Either way, I'm not going to count it against you for increasing and decreasing if they're not brackets. We talked about that in the fourth period. And increasing interval, well, those are the other intervals. So from -infinity to -2, and 0 to +2. Again, this is because the slope is positive. This slope is negative. Concave up looks like in -infinity to -2. And, well, actually, this is like everything. It looks like it's always concave up. So we're not going to have anything that is concave down. Remember, concave up goes up like this, like a parabola. So nothing for concave down. Is this odd or even? Again, this is even because it's symmetric about the y-axis. Okay, so symmetry about y-axis. Mirror image from these two sides here. Local extrema, we really only have one right here at 1/4, and it's a relative because these still go down lower towards 0. So we're going to have a relative min at the point 0, 1/4. It's 1/4 because remember we plug in 0 here, we're going to get 1 over the absolute value of -4, which is 1/4. The end behavior, the limit as x approaches positive infinity. As we go to positive infinity, this goes towards 0, and we know that because the horizontal asymptote right here is 0, and it pretty much always corresponds to the end behavior. So the limit as x approaches -infinity is the same in this case, 0. All right, so those were two more examples of similar ones that we've done in class, and they go through a lot of different things here, but it's about analyzing the graph for its features. Okay, all right, see you soon. Bye bye.